Now that we've learned about some of the parts of the ISS, how would you like to build your own model?
But wait, there's a catch. You have a budget.
NASA Connect traveled northwest to San Francisco, California for this program's classroom activity.
Hi, we're from Alice Long View in San Francisco, California.
NASA Connect has asked us to show you this program's classroom activity.
You'll work in groups to design an alternative space station. Then you'll create a model using everyday items like aluminum cans, cereal boxes, and straws. You'll analyze and interpret data to determine the best design based on budget restrictions, weight, and placement of the parts that you construct. Teachers, make sure you download the lesson guide for this activity from the NASA Connect website. In it, you'll find a list of materials, directions, and student worksheets. We won't cover everything in the next few minutes, but we will give you a general idea about how it all goes together. To begin, your teacher will display the labeled picture of the ISS, as it may appear upon completion. Discuss each component and its functions.
Okay, the National Aeronautics and Space Administration needs your help. They want you to design and build a model of an international space station, and your budget is $1 billion.
Your first step is to construct the components. To power your station, you'll make photovoltaic or PV arrays using transparency film and craft sticks. The thermal radiators used to cool the station are made with aluminum foil. A cardboard tube serves as the docking port. The habitation and laboratory modules are made with aluminum cans. The truss segments used to connect the modules are made from foam food trays. A small cereal box represents the core module of your space station. Buttons are used to simulate the attitude control thrusters. And for the robotic arm, use a flexible drinking straw. Find the total mass and total cost of each component using formulas provided in the lesson guide and record the values on your student worksheet. Before you design and assemble your space station, you need to pay close attention to the constraints listed in Appendix A.
Okay, remember the budget for the space station is $1 billion. If you break a component or a section of the space station, you have to purchase a new one.
Now decide how all the components of your space station will be arranged. Make a sketch before you start your actual assembly, and don't forget your constraints. Use tape and glue to put it all together. When your space station is assembled, the next step is to calculate the total mass. Because the ISS is being assembled in orbit, and not here on Earth, it's impossible to get the total mass at one time. Therefore, NASA determines the total mass by taking the sum of the individual components before they are launched into space. Since we are working with a model, there are two ways to calculate the total mass. First, take the sum of the mass of the individual components, then use your balance to weight your completed model. Find the difference between the two masses and compare the accuracy of massing individual pieces with the mass of the entire space station. If the difference is greater than 5 grams, you'll be charged a tax of $1 million per gram. If the difference is less than or equal to 5 grams, then the space tax will not apply. Record any space tax on the data table. Finally, calculate the total cost of your space station by taking the sums of costs for all your components and any space tax you owe. Did you meet your budget, or are you over budget?
We would like to thank the San Jose AIAA student branch for helping us with this activity. If you would like to learn more about the AIAA mentoring program, check out the NASA Connect website.